The BritChips Podcast is proudly sponsored by Silicon Catalyst UK. Hello, I'm Anthony Miller and welcome to the BritChips Podcast, where I have conversations with movers and shakers in the UK semiconductor startup scene. Now, what do you get when you merge photonics with brain-inspired computing? To be honest, I don't think I even understood the question, let alone the answer. So it's just as well that my guest today understands both. He's Kilian Stenning, co-founder and CEO of London-based semiconductor startup RAYD Technologies, and that's RAYD spelt R-A-Y-D for reasons you will shortly find out. Killian, welcome to the BritChips Podcast.
Thank you, Anthony. Very glad to be here.
And delighted to have you. Look, before we dive into the depths of photonics-based brain-inspired computing, I noted that your first job was as an accident analysis intern with Hitachi's nuclear division, and you were analysing the devastating explosion at the Fukushima nuclear plant back in 2011. How on earth did you get that gig?
Well, this was during my undergrad degree, so I was before I got into physics and all this kind of stuff, I was doing a nuclear engineering degree. And then during the end of my second year, I was lucky enough to be awarded an internship to go to Japan. So that was a 8-week program. The thing with the Fukushima disaster is that all the sensors kind of got blown up. So you were trying to work out what had happened based on a few sensors. So the goal was to try and understand actually what happened on the ground from very, very limited data. That's the story of that. I could go into a lot about all the stories.
Well, I mean, you said you went to Japan. Did you actually visit Fukushima?
No, so Fukushima was just down the road, but we didn't go there. We just stayed in Hitachi. I visited the actual town of Fukushima, which is a bit further on from the plants, but we didn't go to the plant there. I think it's a bit too dangerous at that point.
I was going to say, so you don't glow in the dark or anything like that?
No.
It sounds fascinating, absolutely fascinating. But let's get back to business. Let's talk about photonics-based brain-inspired computing. So please tell us all, what is it and what particularly inspired your interest in it?
Well, I can give you a bit of the story about how it all started, if you like.
Yes, please.
During my PhD, I was working on a different physical system. So it was magnetic-based system. And always interested in how we can offload computing onto some wacky bits of physics. It was mainly kind of curiosity-driven research. We wanted to make these cool systems do some computing. And so for a while, we were developing on that system with my now co-founder, Jack. He was a postdoc in my group and my PhD supervisor, along with Will Branford. And we're doing that for ages, a number of years. We found some really good stuff on that system, but for one reason or another, that wasn't super scalable. And at the same time, some colleagues in the department were working on this photonic system. So it's a semiconductor platform. It uses light.
This is all at Imperial, is it?
This is all at Imperial, yeah.
Yeah.
At the same time, my colleagues were developing the semiconductor photonic platform that showed some similar characteristics to what we were developing before, but it was actually much more scalable. So part of that is Imperial. The fabrication is done with Kirsten Moselund in PSI.
Now she's one of your CTOs.
Yes, exactly. So she spent 12 years at IBM, kind of doing semiconductor processes, leading research there. She's now at PSI, and she's the one that has turned this photonic system into a semiconductor platform. So then,
how did you get to meet her? How did you get to know her?
So this was before I was involved, actually. So Riccardo, who was developing the physics of what's going on.
And he's the other CTO?
CTO, exactly. Yeah, it's good.
Right, 2 CTOs, okay, why not? An heir and a spare, yep.
Well, we're doing really multidisciplinary stuff, so actually right. None of us understand all of it to the highest degree of depth. So that's why we've got quite a big founding team covering all the different areas. Anyway, Riccardo, was doing this stuff on a kind of wacky polymer system. He showed his results at a conference, and then Kirsten reached out to him and was like, I can turn that into a semiconductor platform. And then they spent, a few years developing that. And that's the foundations of the device that we have today.
So where did you fit into the picture? They were working together then for some years. How did you find them or they find you?
No, they're just down there. So Riccardo's just down the corridor. So in a way, you can kind of think of two parallel paths. You've got me and Jack doing algorithms and brain-inspired computing. You've got Riccardo and Kirsten doing the semiconductor photonic platform. And then about 4 or 5, yeah, maybe it was about 4 years ago, 5 years ago, we came together and kicked off the research project, which has now ended up being, essentially RAYD, the technology that RAYD is developing.
Okay, so you and Jack, who is your chief scientific officer, you were kind of looking after the software algorithm side, and Kirsten and Riccardo, they were doing basically the hardware side, the photonics okay. And there was therefore this sort of great meeting of the minds where you thought, why don't we start up why don't we launch a startup? I mean, when did it gel that you had something there that you thought you might be able to commercialize?
So at Imperial, they have these kind of internal accelerators or these like incubator programs. So we did the first one, and at the time it was just like, cool, here's a grant. We can get the grant and do something. Not
Right.
necessarily thinking fully about commercialization, but then we had some breakthroughs in terms of the types of processing that we were able to do. So we're able to classify different medical image data sets. So things like breast cancer tissue, trying to work out if it's cancerous or benign. We did some more advanced things. And at that point, we did the calculations. If this system was perfect,
Yeah.
how better would it be than conventional computing systems? And then the numbers kind of spoke for themselves, and we went, "Oh, okay, maybe we should take this a bit more seriously." So then, probably the year and a half from that point onwards, it was all about getting the business prepared, understanding what our business plan is, what the
And this
target.
was done in conjunction with the Imperial Technology Transfer Office.
Yeah,
Was that part of the process?
yeah. So we were lucky enough to be on this kind of internal accelerator. So they were helping us, thinking about the broader picture of it, not just the technology. And then we
Right.
went through that process, and yeah, we were speaking with the technology transfer office, the commercialization team at Imperial, and then yeah, that's just a couple of weeks ago we finished the spin out process. Yeah, now we're out in the
So
real world.
you're officially a real company.
Yeah, we exist,
Yeah.
which is
Well,
good.
I was saying in my introduction, it's RAYD spelled RAYD. Why don't you tell the audience how you came up with the name?
Oh, it's not that good a story, really. So originally we were called NeuroLays, trying to combine like neuromorphic and
NeuroLens
lays. So it's a
and
laser
NeuroLays.
system, and it does neuromorphic
Okay.
computing. So we merged the words, but then after a while we realized that sounded like a hair removal procedure or something. So we ditched that name, and we were scratching our heads for ages, like what do we call this thing? And we just wanted something short that's kind of memorable. So it's just a play on like ray, like light ray, and then we stuck a D on the end. There's no more
With the D
clever
on
than
there,
that.
why not? Yeah, it works.
Yeah,
That's fine.
it's funny. It's funny how difficult it is to get 5 people to agree on a.
Yes, I was tossing over some ideas for names in my own mind when I saw yours, but most of them had already been registered. So I completely understand.
Yeah,
It
yeah.
takes a while, but RAYD, you are RAYD Technologies. Brain inspired computing. Can you elaborate a little on that and how that kind of fits in with both the technology you're working on and the algorithms you're working on?
Depending on who you speak to, you can call this thing different things. So originally we called it neuromorphic, and in the kind of research world that we used to live in, that was as an accepted term. And, in industry, neuromorphic typically means spiking neural networks or hardware that implements spiking neural networks. But we're not doing that. Instead, in our system, we have some functionality that's like your brain. Particularly, one of the key things is that the system is very, very parallel in terms of how it computes. So you get massive parallel improvements. But the real brain inspired bit is the fact that in normal AI, you typically have one nonlinear activation function. And it's the nonlinearity which gives you all of the processing. Without that, you wouldn't get anything interesting. But in your brain, you have not just one, but like many, many thousands of different nonlinear activation functions. You have some, you have some activations that go up, but then also some activations that, suppress, and that's called inhibition. Like use something called neuronal inhibition. And in
Wow.
our system, we have similar functionality to that. You have a massive range of nonlinearities, and the way that those behave is more similar to how your brain works than how traditional AI works. So that's kind of a bit about the brain inspired aspect of that.
Okay, so it's kind of mimicking, as you say, the way the brain works. What, to sort of recognize patterns of to what end?
Yeah, just like kind of at the fundamental level of how things interact in your brain, just like how these activations behave. But the result of all that, without going too deep into all of this,
No.
the result is that we're able to learn with limited data. So if you think of a human learning something, we learn
Sorry,
it.
you're able to learn with limited data. This is what's making your development, your technology kind of different and interesting.
Yes. So if you think of it, if you think of a human, right, we can learn something just seeing like one or a few examples. We don't need to like replay something, millions of times. Whereas AI does need that. You need to keep feeding it the image. It needs to keep working out what's going on. Our
Well, so it's
system.
like showing it lots of different cats so it knows what a cat looks like.
Exactly.
Right.
Whereas like, we're pretty good at seeing a cat, and then the next time we see a cat, even if we didn't know it was called a cat, when you're a baby, you understand that you've seen that
Got
thing.
it. Got it.
So it's that similar functionality that our device enables. So because we've got these brain inspired dynamics, we're able to learn with less data. So I think some of the examples we've shown at the moment, up to like 30 times less data to get the same amount, get the same accuracy as a conventional AI model. So yeah, this is some of the results. It's not just speeding up AI. It's not just making it quicker, making it more efficient. There's this extra functionality on the kind of algorithm side, which we are most excited about.
Oh, so it's basically a sort of a photonic AI, a photonic based AI processor or co-processor with the added oomph that it requires less data to learn than traditional sort of technologies. Is that sort of the
Exactly.
sum of it?
That's the kind of thing. So, the algorithms that run on our hardware have to be different to conventional models, but you get the huge benefits that come with that.
But does the hardware have to be different as well? I mean, you mentioned about the photonics bit. So where does the photonics fit in? How, what is it? Is it something different about the hardware, or is it just the algorithms, which means you need less data?
No, it's the hardware. The hardware is
Oh, it
definitely
is.
key aspects of that. Yeah, it's important to say that the photonics aspects of this is not like traditional photonics. So in traditional photonics, you typically have kind of silicon waveguides or something like that, and you're sending light down those waveguides, which then interact with other waveguides, and that replicates a operation in an existing system. Our thing is completely different to that. So what we have is our device. It looks like a bit of a random kind of random pattern, but it's not actually random. We're shining light onto the top, from the top down onto the system. And because we're using nonlinear photonics, particularly lasing systems, we actually simultaneously process all of that light, that image input, that light input in one go.
And that's actually processed in the photonic bit of the
Yeah.
technology. It's the photonics that does that processing.
Yeah, so you have all the nonlinearity in there. You have a big, collective process that depends on your input data, and then when we read that out, we are very strict. We only do linear processing in the software. So really, all of the computing power is coming from the photonics bit.
Wow. So, I mean, what sort of things can you do or are you doing with it? I mean, earlier on you talked about analyzing breast cancer cells. I mean, just out of curiosity, where do you get that data from? Does Imperial have a sort of a source of data on all this sort of things for people like you to try and analyze?
No, this was actually a publicly available data set. I think anyone could download.
Oh, okay.
It's really, even it being at Imperial, it's really hard to get your hands on data like that. Um,
Right.
Yeah, so what we've done so far is mainly on image processing. So our system accepts 2D kind of matrices, i.e., like images of data. So that was the first thing we've tried, basically.
Right.
Uh, Entirely image processing. You can do all the classic benchmark tasks like the digit classification and these different types of things. And then from a research perspective, we wanted to do the medical image processing because it is a good example of where you don't have much data. So you might only have 1,000 images in your data set, whether that's for privacy reasons or other things. So it's a really nice test bed for us to show off how good it was at learning with limited data.
And what,
But
what what sort of images would these be? Are they like, I don't know, X-rays, or are they images from scanners, or what sort of images are you referring to?
so the things, it was like slides or like microscope images of breast.
Ah, of slices, yeah, of yeah.
So yeah, that's the most thing. But we can do things like X-rays. We can do a whole range of things. It's just how much how much time we've got to try them is the
Sure.
main thing.
Okay, and you're saying you work from a relatively small sample of those. The big test was, can you work from a relatively small sample of those to generate some sort of meaningful analysis of what it means? Like, in the example you were giving, like, oh, we found some cancer cells or something like that, or abnormalities anyway. Okay. Mm. So where are you at? Yeah, sorry, Corey. Sorry, yeah.
Oh no, just because yeah. So the goal of that task in particular, you had 1,000 images. Some of them were cancerous, some of them were not. So the goal of the machine learning was to say, detect the cancer in there. But we've done other things similar to that. Yeah.
So where are you actually now then in the development process? Well, it sound, you've got the photonics sort of hardware bit, and I assume the bits you need sort of traditional silicon to kind of go in and go out. What does this thing look like, and where are you with it?
Yeah. So the device itself, this kind of mesh that I've been talking about, that is about 100 microns in diameter. So, really, really small, super, super.
Right.
Um, but where we're at now is, the surrounding stuff that we need to get the light in and read the light out is currently like 30 by 30 centimeters in the lab. So it's this big unit. Um, so yeah, we've got a lot of extra space and a lot of extra kind of research equipment around this tiny device. The goal on the hardware side is to shrink that down. So what we're working on at the moment is first making that system more robust, and we're going to set up a remote server which people can log on and start to try the algorithms on their own data. And then at the same time, we're going to take that big kind of 30 by 30 centimeter system, make it something like 10 by 10, 5 by 5 centimeters, make it portable, and we can actually go out and test it in the real world.
Okay, I'll come back to that in a second. You said people can try out. Who are you designing this for? Who has shown interest to say, yeah, can I try this out?
We've had some interest in robotics, actually.
In
So
robotic, oh, well, in image recognition for robotics applications.
yeah, there's a few different things. In robotics at the moment. Maybe you've seen like the fancy humanoid robotics that are going around, and they can do all their funky like flips and things like that. Um,
Yeah.
Eventually, when you okay, so the way robotics works at the moment is all of the training and all of the learning is done in the cloud, and then you deploy that model, which is frozen. It can't learn anymore. It's fixed. You deploy that onto your robot. And one of the big things in robotics is that typically it might encounter a new object, or it might encounter a changing of environment. Things don't match the simulation perfectly. So you want to be able to have some learning on your actual robot to adapt to those things. Maybe a sensor fails and it needs to adapt to the fact that the sensor has failed without having to send the robot to be repaired. So there's been some interest in that side. Um, and being able to learn about new objects actually on your robot. But the truth is, we're still quite at we're very at the very beginning of our journey. We've still got a lot of tests to do on the hardware, a lot of algorithm development to do, and we think we can go beyond just images and do a whole range of different things as well. So that's part of the plan.
Well, I mean, in what sort of time frame would you expect to see people like these robotics companies or whatever actually, going at it hammer for tongs, testing out the model in the cloud?
We're hoping to have the first version of our server set up by the end of the year. So
Or
we've
the end
got
of this year,
I
right?
hope so. But yeah, we're already 4 months into the year, so let's see.
Yeah.
But fairly soon, we don't need to do too much development in order to get that up and running. In fact, like the hardware that we run in the lab at the moment, we already kind of remote connect to ourselves. It's just we need to make it more robust and we need to make it, nice, basically. So end of the year, maybe at some point, halfway into 2027. Let's see how it goes.
It's good, yeah. Because it says it sounds like most of the work you're referring to is actually the hardware work. So that's sort of Kirsten and Riccardo. They're now sort of heads down, tails up, trying to refine the hardware and sort of miniaturize it at the same time.
Yeah, they're guiding the project. We've got we have some. Well, soon we'll have some engineers that will be actually doing that work in the lab. We have the research teams already at Imperial and PSI who are kind of doing adjacent work as well. So that's
Sorry,
going
PSI, PSI.
where Kirsten is in Switzerland.
Oh, right. Sorry. Oh,
It,
that's right. She's based in Switzerland. Yep, yep, yep.
so yeah, no, we'll have engineers do that, so to actually like build the stuff. Um, but yeah, I think that a lot of work is on the hardware, but a lot of work is also on the algorithms. It's really both. So you know, we've done this quite impressive image processing, but there's a
Yeah.
lot of work to be done to make that, to improve that, to make that suitable for robotics, for other types of applications. So it's really like a kind of 50-50 split between the two aspects.
Is there kind of a sweet spot application then, a sweet spot use case for your technology, or is it really just so broad and you're just picking the ones that you think, well, that interest you and see where it leads?
Yeah, so robotics, we're focused on robotics a fair bit just because from the perspective of the hardware that exists at the moment, I think like being able to learn on the robot is potentially a very attractive thing. And
Yeah.
the learning phase for robotics just takes a very long time at the moment. And in terms of the particular task, being able to identify a new object on your robot is going to be important. Um, but yeah, longer term, I think we can do a whole range of things. Like we don't plan on just stopping there. We're focused on robotics at the moment. We need to
Yeah.
see how the next 6 months go in terms of the algorithm development and the hardware development. It might be that we try some different task and it could be much,
See
much
how
better.
it goes.
Yeah, yeah. It's still, we're still doing, you know, not necessarily fundamental research. We're still doing a lot of development to work out exactly, how far can we push this thing.
Yeah. Yeah. Now you mentioned actually just before you're going to bring on board some more engineers. Obviously, they require feeding and watering, as do you and the rest of your co-founding team. Can you talk a little bit about the founding? Sorry, about the funding, because you said I think in the early stages it was sort of grant from the university. Have you raised any funding since then?
Yes, we've got so we're getting some funds from the Royal Academy of Engineering. So they've launched a new scheme called the Green Future Fellowship just this year. And I think we applied for that back in November 2024. And yeah, we're successful. We got it. It's a few million in funding, which is, will get us going. We don't have a clear date on exactly when that's going to be in yet, but hopefully very soon. And then, yeah,
But it's committed. They said yes, we're going to write you the check, and it's in the mail.
we're committed. I think we still got some small details to iron out, but yeah, that should be coming in.
And you obviously that's what you need to be able to trigger the next hiring phase, I assume, and
Exactly. Yeah.
development. I assume it'll be used actually for both, will it? For hiring and also continued development on both the software algorithms and the hardware.
Exactly. So that funding will get us to be able to set up this server, and develop the algorithms, develop the hardware further. So yeah, exactly that.
Right, that's good. And how long do you think that funding, you said a few million, I think it was 3 million, when we were speaking before.
Yeah.
How much runway does that give you before the sort of the next milestone, so to speak?
It depends on how well the technology progresses. So
Right.
we're going to hire the core team, and once we've done, then just with that core team, it could last, a year and a half, 2 years, maybe a bit longer. But if technology goes well and then we start recruiting more, then that runway decreases a little bit. But we'll be trying to, at the same time this year, we're going to be launching a fundraise at some point. Um,
Yeah.
so, so yeah, we're just waiting to get a bit more progress on the tech, and then
Yeah.
we'll be trying to raise more funds.
And do you think, as you sort of put this out to organizations to trial, do you think you'll be able to get some sort of co-funding from them as well, which might sort of accelerate the development process?
Exactly. Yeah, that would be the hope. So we can use this remote server as a tool to get people, to kind of do the evaluations,
Yeah.
uh, and then, depending on what this end user's specifications are, we can then start to hopefully get some funding, maybe some proof of concept or some co-development funding to turn that server into something they can go and actually use. So the kind of miniaturized version I was speaking about before.
Yeah. Okay. Well, that would be good, and that would certainly accelerate things. Now, I think the way that I first got to hear about you and RAYD Technologies was actually through the ChipStart program, because I think I saw you at the graduation ceremony. I might have seen before, which was just a couple of months ago. That was a 1 year program now, so you must have started in sort of Marchish the year before. What was your sort of expectations or hopes that you would get out of ChipStart, and did it do what you were hopes it would do for you?
Yes. When I start, so I very nearly didn't join ChipStart, and luckily,
Oh,
luckily,
okay. How did you get to hear about it? I mean, how did it all come about?
so there's a few people so I was originally on this other accelerator, which was focused on AI, so mainly on the
Right.
algorithm side of the technology. And Alex, who is the founder, I've forgotten the company name, but Alex at Imperial, I think he's done a podcast with you. He was on that program and advised me to go onto the ChipStart program, which he was in cohort 2 for. And
Ah, okay.
then I realized that, Mint Neuro, Dorian at Mint Neuro had also been in cohort 1 of the program.
Yeah, you knew Dorian?
Yeah, me and Dorian had interacted because we're both Imperial based. I'd reached out
Oh,
to
of course. Of course, of course, of
He was
course.
giving
Yeah,
me
yeah,
advice
yeah.
on how to get going with all of this stuff. So yeah, so that's how I heard about it. I did the application form when I was placed, but very nearly didn't sign up. But luckily, they convinced me to. And I guess what I was expecting to get out, I'd say at the point when I started, I didn't, I had an idea of what we wanted to do.
Hmm.
Technology was working well, but in terms of like the connections or the ins and outs of running a semiconductor business and all the various things you need to think about,
The
uh,
commercial side, the business side, the networking side. I mean, networking as in people rather than
yeah,
bits and bytes. Yeah.
yeah, exactly. So I knew the technology, but there was a big gap in terms of getting this spin out started. So I was mainly looking for help and support in doing that, and connections, both connections to people in the industry that can give advice, connections into potential customers, those types of things. And yeah, the program was excellent. It delivered on everything that we wanted it to. Really had a great time. Yeah, we were lucky enough to go to San Francisco, which was very nice.
Wow.
And maybe the biggest value out of all of it is that's where we met our chairman, Robert Swan. So he joined us via some connections we made in the ChipStart program.
Okay, I don't think I know of Robert Swan. Where does he sort of play in the firmament? Hmm.
Robert Swan is, so yeah, he's our company chair. I think he has a long history in the semiconductor industry in the UK.
Okay,
I think he founded Alpha Mosaic. He's founded a bunch of other companies,
right.
which have, all gone on to big exits. I mean, having him on the team is great. We're four people from the academic and the research world.
Yeah.
some commercial now has really, yeah, it's really helped everything.
I mean, do you see yourself sort of taking more of a commercial business side? If you sort of think ahead a few years, obviously, as you say, you're still in the early stage and you're deep into the software, the algorithms. Does the business side of running a startup and hopefully a scale up and who knows, a global champion, does the business side of that attract you? Are you burning to be an entrepreneur and go sort of boldly forward?
Yeah, 100%. I mean, I don't think this thing would have started if I didn't want to do that.
Well, that's probably true. Silly question, Miller. Silly question.
I mean, yeah, I can very happily just, we all could have just carried on developing this thing in the university, and that would have been, fine as well. But no, I've always been quite interested in entrepreneurship and the kind of business side of things. So, yeah, I'm super keen to see where it ends up, how it all goes, and it's just like the excitement of doing something new and learning new things every day. That's beyond the technology, just like how you run a business, how you speak to customers, you know, analyzing markets and all these different things.
Well, that's great. That's great because and there's nothing wrong with this. There are obviously some entrepreneurs, startup entrepreneurs who have come from research like you have, and that's their thing, and that's what they would just want to do. And you see that although though they are initially the founders of the company, they then at a certain point of maturity say, well, look, I'd really like to carry on the technical side, and then either someone else within the company or more typically they bring in someone like a Robert Swan type character to sort of lead from there on in. But it's just it's kind of whatever is your bag, so to speak. And I can see what yours is.
Well, ultimately, it comes down to what's best for the company.
Exactly.
I've got the intention to go just to keep going with it, but if it gets to a point where there's a different route that's better for the company, then that's absolutely fine as well.
Yeah, or a better route for yourself. I mean, do you see yourself as a serial entrepreneur? As you get. I mean, who knows about the future? But that's the sort of thing that I get the feeling does sort of inspire you.
Yeah, let's see how it goes. I think I'm so head down.
Completely get that. Well, you and your founding team, have gone through a lot from sort of the original research stages to where you are now. As you said, just a couple of months ago, you became a fully incorporated business. You've got sort of prototype things. You're going onwards and upwards. If you look back now, or if you meet a researcher at Imperial who's where you were, say, 10 years ago, and said, Kilian, I'd really like to start my own business. What's the most important piece of advice, or what's the most important thing you think I should know to make it successful?
I would say you just got to keep trying, like throughout the whole process. Like there's many things that pop up that make you go, oh, maybe we shouldn't do this, or maybe whether it's like the technology is not quite as good as you want it to be, or you're not having that much luck with like speaking with potential customers. I think if you've got the passion for it and you just want to do it, like just keep trying. Like we were lucky, we had like a really great piece of tech, so my life before this has just been focused on developing cool technology, and having that has made the prospect of this, really well. There's a high potential for it. So yeah, don't know. It's hard, isn't it?
Yeah, I mean, you could look at it another way and say, is there anything that you know now that you wish you knew when you started things that 5, 6, 10 years ago?
Yeah, I guess. The technology, when you're as a researcher, you're all absorbed by technology and what you're developing. But that is only, some percentage of the total thing it takes to run a business. And so you really do have to think about, the market side of things, the financial side of things, all of these different aspects. It's not just the technology that makes a company, it's everything else. So,
the people, especially the people.
Especially the people. Exactly. Without a good team, either won't be enjoyable or it won't work.
Well, the thing is, you're the CEO, so you are therefore the leader. Do you like being a people leader? Do they like you being a people leader?
They haven't told me otherwise.
Early days yet. No, you must be doing a great job. Well,
No,
this is yeah. Yeah.
yeah,
Just one sort of last thing. Are you aware of anybody else or doing the sort of thing that you're doing with this photonics sort of AI edge thing accelerator processor?
yeah. I mean, in the research world, there's like quite a few groups that do, whether it's photonics or whether it's a different flavor of technology. There's a few people working on this type of stuff. There's not so, at least what I'm aware of, not so much actually on startups, I think. But
Ah,
maybe there's some stealth things coming along. Yeah, I don't know. But yeah, this exact technology, it is quite unique. I mean, so Riccardo, who's been developing this stuff, it's been the last 10 years of his life have
oh,
been
right, okay. Yeah.
developing this stuff. So it really took a long time to get to where we are today.
Yeah. So
So
it sounds like you've got a good sort of lead on certainly what you can view out in the market, which doesn't sound an awful lot. As you say, you don't know what's going on under the covers, but you're there, you're out there, and hopefully the podcast like this will help sort of spread the good word, as well as ChipStart and follow-ons from that, which would be absolutely great, because it
yeah,
sounds like what you're doing is really exciting stuff. Well, certainly look forward to following your journey to the next stages, and we will stay in touch. So Kilian Stenning, co-founder, CEO of RAYD Technologies, spelt RAYD. Thank you very much again for joining me on the BritChips podcast.
thank you very much, Anthony. Lovely to be here. Cheers.
Thank you.